Hello, guys. I hope you guys are doing well. We are back again. It's rather unfortunate we will not be able to meet face to face, but I decided to make this video for you so as to enable you have direct experience to all what we started last week. And so this week we'll continue. Already we started discussing database and database management system. We try to understand what database is. We indicated that it is a computer structure that enables us to share and store data in a way that enables easy retrieval. Database basically is composed of tables. It's the tables that make up database. Okay, and we indicated that a typical database will have fields. Now, these fields are the columns when compared to any front-end development application. A normal form where your name, your index number, your date of birth, and what have you can be collected. And so that is what the fields represents. And when we talk of a record, we are referring to the longitudinal, right, approach. In other words, the rules, which is able to tell that this person, assuming the webmaster, has a username and then has a password and can also be identified by his role as the super admin. So that is what we have now. And we looked at the database itself. We indicated that the application that runs it is called the DBMS. And so we got introduced to MySQL, where I even showed you the interface of how MySQL looks like. And so let me bring out. So here, when I go to localhost, phpMyAdmin, it gives me the interface for connecting to the database. And we are using, from this day forward, that is what we'll be using to interface our database platform. And so we indicated that banking applications, social media applications, point of sale, school management systems, all of this have database management system at their backend that is capable of storing data. And we indicated to you that when we even go into the Asempa database, it's actually an application that has a database backend. And so when we go to Asempa, for instance, let's say localhost Asempa. Asempa. It's supposed to bring us the application that we have going on. And behind that application is where we have the database that stores every bit of data. Okay. So this is the Asempa Filler application. Okay. But when we when we say want to access the user's platform, you see that here the user account has two important fields. We have the username and password. When we go into our database too, we are able to see that if we go to the users table, this is the users table. When we go into the users table, we will see that we have these columns, all right? These are the columns, and this is the row. This is the row. So when we come to this column, you see we have a UID, we have a name, and we have a password. We have a number of them if we continue scrolling, right? So now this actually represents our database. That is, this is a well-structured application, right? That is just to let us in on what it is here, that if you use any electronic application, all right, chances are that they are actually having database at their backend, and exactly what I have just shown you. So this is the application, and when I log into it, it uses the webmaster as my username. When we come in here, you see it there, okay, and the password has been hashed. So when I logged in, this is what we have. So it's most likely having a database backend. That is why you are required to learn this particular course or to take this course so as to enable you be able to develop going forward applications that have the ability to store information. Okay. And we discussed the purpose of data systems, what exactly they are. And we also looked at who are the actors. Okay. If we say systems administrator, who is a systems administrator? Who is a database administrator? Who is a database designer? So all this come in handy. You've always been hearing of them now. You should be able to understand who exactly they are. Okay. So going forward, we'd like to look at the difference between data models for today, schemas, and then what are instances. Database schema or database instance. The database schema actually is the blueprint. So as time goes on, I'll show you what exactly the blueprint is. It gives you the opportunity to create database, okay, that does not exist. Okay, and so when we say an instance, this is a fully operational database that contains the data at any given time. Right, so we can qualify, we can say that this, what we have here, is an instance database because it is functioning, it is operational. Okay. Whereas a schema might just be a representation of the items that go into the database. Okay, so it might represent the two. Let me show you an example of what database schema is. So assuming I go in here and say I want to export everything about this. Okay. Excuse me, let me get something done out of that soon. Okay, I'm back. All right, let's continue. So data models are defined as the structure, all right, that can be processed and stored inside the system. And they are usually graphical in nature. They are like data structures and their properties. We have relationships, constraints, transformations, and whatnot. Now, a data model can, for example, be a relational model where data will be organized in tables. All right, so I was about to show you how the schema looks like first. So let's go down to okay, let's go down to the application first. So when we get here, we can export all of this. So assuming we go to the Asempa, click on Asempa. Okay, we see all this. We can check all and say export. Okay, so I want to export the Asempa database so that you can see what exactly I was referring to as far as the schema is concerned. Okay, so this we go. Okay, so it will download the schema for us so that you see how it is that the difference between the schema and then so this so this database schema and the database instance. So let me show you what the schema is. So this Asempa, you can see here that we have the Asempa. So when I go in and then right click on this and say it should open in there's a VS Code. Okay, let's open the VS Code and let's see how it's going to look like. So opening the Asempa database, you see that this is what we call the database schema. Okay, as it says here right now, this is the entire database. Oh, you can see. Okay, this is the entire database. But in this format, it is not a database. It is referred to as the schema. Okay, so everything about the database you are seeing are here. All this is the schema. So when I run this in an SQL command, it will still create this whole thing for me because there are instructions in there. So you can see here that it says create table actions. Okay, and it's going to create it and tie it to the engine InnoDB. You can see. So it's actually going to create it and do all that for it and even insert all this data into it. So if you want to even understand how databases are created, you can even use this to see, say, create database. So you can see here that it says the database Asempa. That means that it is assuming that you have created the database Asempa. And now you want to now create the tables in it. So that is why we have this command here. But assuming we did not have that, then you can say that it should create database, right? Asempa. And then in it, you say use database Asempa. Then it will use it and start creating all this. So you see right from here, all this, you see, create the table cache update. Insert into the table cache update. So this is what we call the schema. Right. So after this, we can now look at the instance. So this is its instance. So when we come to the Asempa, This is the instance of the database that we have. So what you are seeing here are actually live. They are operational. All right. So that's the difference between the database schema, which is a blueprint created when the database does not exist. So what I just showed you is the schema. Whereas the database instance is a fully operational database that contains data and at any given time. So you see, at this particular point, this is operational. That makes it database instance. But what I showed you about the schema is not an instance. All right. However, it still can be used to create the database. I hope I've made myself clear with that. Good. So we move on to data models. As I told you, these models are the relational representations. It gives us the graphical representations of how we can model data. So let's say we want to discuss what exactly these structures are. We use the SQL language, or in other words, the structured query language, to create databases. Now we have 4 categories of these. We have the data definition language that is used to create. We have the data manipulation language that is used to manipulate. Oh, I think this has been repeated. Okay, this has been repeated. The manipulation commands are actually insert, update, delete, retrieve. Okay, these ones are for creation. All right, so please take note of that. I will serve you a different stuff file next time. So the data control language. So assuming when you create a user, you need to arrogate certain roles or privileges to a user to be able to do certain things, to update, to delete, and whatnot. So we use what we call the grants. So it is data control language. We can also revoke the privileges of a user. Okay, so these two are known as the popular data control language that is used to control access. Then we have the transaction control language. Okay, this is also used to control transactions. Now we have commit, we have rollback. So these are very few commands that we use in controlling the transaction languages. All right, good. So we move to database system environment, and I've shown you most about what exactly the environment looks like. So we can skip this. All right. Okay. Okay, so when we come to database architecture, we have the tier 1, which actually has to do with the client, the server, and database in a live computer. All right. So example, we have all at once, assuming my computer is one that has a server and that has a database in it. You know, the database I created. So now this is basically when we go in here, this is as a sets now. This is a whole database that is sitting there like that. This is a database, right? So we need to also have it in the database management system. So we have run a database management system, and this is our database management system. Okay, and they are all on my computer. So invariably, that is what this statement seeks to establish. So we have the single tier, meaning we have everything in it at once. And we have the tier 2, or in other words, the 2 tier, where we have the application sitting somewhere, and we have the database also sitting somewhere, and we have the machine also sitting somewhere. So at the end of the day, it's going to connect to it. So you can see that we have machines connected. So right now, we can, since my machine runs on Apache, we can get connected to it and all access the database at once. So this is what we call the two-tier architecture, where we have the database sitting somewhere and you guys can connect to it. Now we have the three-tier architecture. So we can dedicate a whole server, okay, to now be managing the databases. All right, so we have the client, we have the server, and what we have the database. All right, so that is another aspect of controlling the architecture. All right, whichever way, the whole thing is about security. Once you are able to get a system secured, you are good to go. Okay. So we need to classify database management into relational and then into object-oriented database. So when we look at this, we realize that this is a typical way of actually dealing with database, where we have, we can write an SQL statement for it to pull records for us, right? So when we talk of the relational database management system, it's a program that uses the rows and columns to organize data in two-dimensional tables, right? When we say two-dimensional, we say there are rows and columns. That is what they represent. And databases, MySQL, and whatnot, all use this particular attributes, okay, where we can assign a primary key, okay? We can assign also a unique feature to a particular field. So object-oriented programming also depicts the normal way of OOP, object-oriented programming, where we have inheritance, we have the type calculation, we have polymorphism, we can mention that we have abstraction, right? So all this actually are simulated, or they are concepts that actually help us to appreciate and understand database. And we have the hierarchical database, where we have, it's like a tree, okay? We can say that a college contains students, teachers, and administrators. And students can further be broken down to these other fields, where we have the index number, we have the name of the student, we have the age of the student. We can further drill down these other aspects. Teachers might have a special identification number. They might also have courses that they teach, you get it. So that is what we call the hierarchical, all right? Okay. Good. And in it, you can identify that we have one to many, all right? We also have many to many, all right? So when we come to the network database, that is where we appreciate the one-to-one, and we have the many-to-many relationship being established. All right, so we can see teachers who might have different kinds of, we have different teachers who will be teaching different courses, all from different departments. So that is typically about that. All right, so we move to LO3. Now we will be doing some demonstration of skills here. So here, we would want to look at the database design process, entity relationship model. Okay, we will also perform database normalization. We will draw the entity relation diagrams, okay, and convert them to diagrams so that we can implement them in the MySQL server. So maybe we will deal with the performance of the normalization later, but let's go on. So to discuss the database design process, we need to understand that there is a system development lifecycle that we all agree to. And this is a continuous process of making, maintaining, improving, and replacing information systems. Now, when we get to the database lifecycle, in the first phase, we have the database initial state. where you tend to appreciate or analyze the company situation. What exactly is it for you? What exactly are you going to develop? Then you will define the problems and their constraints. You also define objectives and define the scope and boundaries. Now, when it comes to the design stage, that's where you create a concept, or another word, the conceptual design. So the concepts are actually what is going to be implemented. All right. And so once you have this, that makes it things very professional. Once you are able to conceptualize the designs, then it means it becomes easy for you to know what you are doing at any given time and what you are going to collect at any given time. And so with the design process, we have the conceptual design, where we have data analysis and requirements, data relation modeling and normalization, data model verification, and also distributed database design. So now this is where we are going to sit down, doing an analysis and then the data relationship. So when we say entity, what are we referring to? The entities are, presumably we have maybe we, in the case of a customer trying to buy something online, okay? We can see that the customer is an entity on its own. The order itself is an entity, and then the product is also an entity. So since they are entities, it is required that we are able to break down what goes into the customer's table, what also goes into the orders table, what goes into the product. It could have just been easy to just say that the customer has bought a product. But in between, you might not know when the person bought it and where exactly the person bought it. You might not also know the product identification, things that identifies the product. You might not be able to know. So this, how we call the bridge table. So between the customer and the product, we have a bridge. So that bridge now becomes the order table, where you place order and all the other details are captured. So when we get to entity relation model, we say that the entity relation model is a list of all the entities and attributes, as well as all important relationships between entities. This is what I'm referring to, that a customer wants to buy, maybe want to buy jeans online. Okay, so once he makes payment, purchase, his name is captured. Okay, the region in which the person is, the city and the suburb, or the person's phone number or contact are even collected. Now, between that and the product, all you want to know is, okay, how many items of jeans do you want to buy? Any particular type are you going in for? What do you call it? We have different types of jeans, right? We can say we have the ragged ones that are torn. We have the neat ones too that are blue jeans, or we can even have a khaki looking jeans. So these are the types. So the product table will hold that information. And in between, what you're going to order, you must have information about it. All right, so this gives us a background information, like the descriptions, data types, and constraints. All right, and the model does not require a diagram, but a diagram is typically a useful way to do things. Nowadays, we have systems, we have chatbots that even make it easier for us to render our things in a particular way. Okay. So let's say that we have representing entities, and this is to help us visualize the design that we intend to build. All right. And usually the ER diagram represents an entity set by a rectangular containing the what? A rectangle containing the entity name. So we'll come to that in a minute. But let us look at the attributes. So we can say that the identifying attribute or attribute from a unique key. In this particular case, we call it what? The primary key. So now the primary key is what you're going to use to denote that field that we can use to identify the table. All right. So it's very necessary that we understand what exactly we are doing. So when we go to the representing relationship, we can say that we have many-to-many relationship. We have one-to-many relationship. We may have one-to-one relationship. Okay. So that is because we will need it to establish relationship with the other tables. A table exists alone, but it is much more effective if it is in relationship with other tables, and the connecting tissue there will be the primary keys, and most recently another one called the foreign key. As a matter of fact, the foreign key is just like the primary key, but this is when it is found in a different table. Then it becomes foreign to that table. All right. So that is what it is. So that is basically that. And to perform database normalization, you have to understand that normalization is a process for evaluating and correcting table structures to minimize the data redundancies and to also reduce likelihood of data anomalies. So I said the last time that repetitions are not welcome in database modeling. So in order to take care of things properly, we have what we call the normal forms. We have the first normal, second normal form, we have the third normal form. We even have a fourth normal form. All right. That is if the third normal form does not satisfy what we're going to design, then then there will be need to have a fourth normal form. But aside that, the most important ones you need to know are the first normal form, second normal form, and the third normal forms. So what are the characteristics of these? We are saying that in the first normal form, the table format has no repeating groups, and then the primary key must be identified. We will soon get to that. Okay, the primary key must be identified. And then we can also talk about the second normal form, which actually is the first normal form, which has no partial dependencies. So mean that there are no strings or things that would make it not look so general, but must be specific. Okay, and the third normal form is the second normal form, which has transitive dependency. So I mean that in terms of normalization, we need to start from somewhere. So we have a table, for instance, that looks like this. You can see that we have these columns. We have the product number, product name. And in the product number, you can see that there are some unique values that are in place there. But in the employee number, we have a number of employee numbers who have almost the same product number, who might also be having different charge hours. When we say charge hours, yes, it will depend on the employee's job class to have different charge hours. Obviously, you will not say that one who works as a cleaner or a janitor will have the same pay rate as a lecturer would have or as an administrator would have. They all have different billing points. Okay. So that is what has been captured here. But when we go in to the first, normal form, we put things in perspective, right? So you can see that we have all these 5, 1, 2, 3, 4, 5. The evergreen project name, okay, being associated with different employee members with different job titles. So this kind of makes the table look uh, kind of clearer. That is what the normalization does, meaning that you are putting more meaning to the table. So you see that when we further drill it down, we are just trying to make sure we can identify the primary key. So in our case, these are repeating, so we can't make it primary key. These names too are repeating, we can't make it the primary key. So what else can we do to get this being a primary key? So when we get here, you realize that we are saying that the casual observer will see that the product name is not adequately positioned to be called the primary key. All right. However, we can identify other primary keys when we do some conjectures, when we combine. So we can see that in step 2, which means that we have already identified the following dependencies. So here, product, or we can say project name, okay, project name, and then the employee number, all can depend on what? The product name, all this. So we can say, all right, that the product name is dependent on the project number. Right. So what are we trying to say here? Let me go down and see how best we can put all this together in a format that you can better appreciate it. Okay. Okay. So before that, let us look at the ER modeling symbols. We have the typical ones that we use are the crow's feet. So you see, this crow's feet means that many to many. All right. Okay. So if it is optional, we can say 0. So this symbol you are seeing there means the option symbol. And we also have the one-to-one, okay, showing as this, okay. And we have the entity being and we have the relationship line, okay. So we can design this by using Microsoft Visio to get it done. But in a much more contemporary term, Windows 16 is quite a long time ago. Nowadays, we can use what we call the Lucid. Okay, Lucid. So let's say I come to and type Lucid. Let me go to Google first. Google. Then use Lucid. Lucid chat. Lucid chat. Good. So we can use the lucidchat.com. Okay. So let's go in here. See what the Lucid chat will give us. So you see that the Lucid chat actually gives us the opportunity to create this data relation diagram so easily. Okay. Let's log in. Okay, so all you just need to do is to sign up using your Google account. Okay. So we can start our new product. Here's what I want. Here we have the entity relation table. This is what I want. So with this, you're able to stretch it and bring in. Okay, so we have two entities or three entities. Okay, so we make it. Okay, so here, as we rightly said, we can call this the customers table. Customer. Now we'll call this the order table. Order table. Now we can call this the product table. What I'm doing is I'm just double clicking on it and giving me the opportunity to change. So with this, okay, bring it a bit closer. So in our customers table, there are things that we want to look at. So we want to look at the customer's ID. Okay, customer ID. Customer ID. Want to also look at the first name of the customer. Want to also look at the last name of the customer. Now, assuming you are stuck, you can right click on this and then it would give you more rows. Right? Right click and then set more rows. Okay, so you come in here and we set the region the customer lives. We also want to look at the city the customer is coming from. And above all, we want to have the contact telephone number of the customer. Now, when we come to the order, we want to know the order number. Let's call number. Okay, so we can make this. We have the order number. Then we'll change this to the customer ID. All right. We can change this also to the customer's name. We can add more. We can add more rows. So we can add the region to which this particular order is being made. So we can say region. Okay. We can also say the city to which this order is making. City in above all. We want to put in here the product ID. Okay. So when we come here to, we'd like to make some arrangements. Stretched. So we'll come in here and give this products ID. Product ID. Okay. Then give it a quantity. Then we'll give this the product type. Okay. So having done this, we would like to this number. Okay, so this is a typical example of the tables we are referring to. Okay. These are tables we are referring to. But now they are existing on their own. They are not linked in any way. Okay. They are not linked in any way. So how do you identify them? To identify this, all these entities, these are entities, right? We'll have to make sure we set a primary key. So we can call this PK. Okay, delete this. Delete this. Now, the customer ID should be an integer. So we can say int. Then we'll give it, say 6, it should have in terms of length, 6. Now, when we come to this, we can say varchar, varchar. Okay. Varchar, we can give it 50. Make this bigger. Okay. Yeah. So when we come here, we can also make this the same. So let's copy this and put it in here. Varchar, so 50. Region to Varchar, 50. City, Varchar, also you can make rather this one 20. It's too long. And make this phone number. So phone number 2 should have an integer, so we can call it int. Okay, and to give it 10. Okay, so that is about that. So when we come into this one too, we would like to make this the PK as the primary key. We'll delete these ones. Okay. Now this one too must have. So you can call this int. So you see the designing stage. Almost everything has been captured. Okay, let me make this bigger. Okay. Of this backward. So, function. Customer ID. No, customer ID must be an int. Okay. So customer ID should have also 6. Depending on how I want it to be. The customer name will be varchar. So 50. Region varchar. So 50. City varchar. Also 50. No, I made it 20. Product ID. Int. When we get to this point, we want to make the primary key for the product. You see, PK product key. Then this will delete. This will delete. I will make this one also int. Quantity. So it should be int. So quantity we can have. Also 6. Let's make it 6. Then we have product type. That's a varchar. So now you can see that with this, we have been able to establish 3 tables. This one, the order becoming the bridging table. Okay. So with this, we can establish the relationship, the entity relationship, right? So to do that, it's easy. We can just, but before then, for us to have the relationship might exist before we can put in certain keys, okay? So in the first normal table, we have been able to identify the primary keys. So that makes it our first normal table. These are first normal tables. Okay. Right. Now we want to establish the relationship that must exist. So when we come in here, this, okay, for us to establish that, we just put in a line. So we just click a line and just connect to this. Okay. So we need to further specify what type of connection we are trying to establish here. So we say this is a customer. Customers can make orders, right? So can a customer make, in terms of maximum and minimum, how many can a customer order? And so we realize that one customer can order as many. Okay, so if you can order as many, then it means that we want to have something looking like this. Okay, that the customer can order 0 amount of orders and can equally also order up to 100 million. So many get it. So that's what it means. A customer has the opportunity to create, can please us no order at all. So that is in the power of the customer. Now when we come to the customer itself, in the customer's table, when we come here, we realize that the customer has an opportunity to place an order once. Okay. Okay, so if that is the case, then I guess this is the point we need to establish. Okay, that the customer has opportunity to make one order and then place an order one at a time. So we have 1 there. That's the minimum. Now, when we come into the next one, the order that's going to be placed for the product, we'd like to know how it's going to be done. So we can have an order coming in for so many products. Okay, one order can have so many products, right? So just like you go into a market to say you're going to buy items, when something catches your attention, you can still buy it as long as it's in your power. So you can actually create more. So with this, we establish the connection. Oh no, we establish the connection here. Yeah, establish the connection here. So you can see that we have one to many. Okay. Then this particular one, what does the order do? At any particular point, this order can be placed once, but the order or the product can even be 0. You can have 0 products from an order. So we want to say that it should be looking like this. So we'll have this showing, okay? Right, so this is what we've been able to establish so far. Okay, so having established this, then we can as well look at the foreign keys. So what are the foreign keys here? So to establish a foreign key, we can see that we have the customer ID still being found in here. Okay, so to make it complete, we introduce what we call FK, signifying what? The foreign key. So FK can be established in there. So we can say that instead of we having this, we can move this. Okay, we can move this. Oh. Okay, so we can move this. I'm trying to move this now to this. Okay, so that it becomes, and then we can also move this to this. Okay, which will represent our, so we've tied this key to our foreign key. I think I placed a foreign key here. This will be a foreign key, FK. So I'll rather bring this one down. Down this way. Right. So we have the primary key of the customer's ID being tied to the customer's ID, okay, in the order, making it so we can also tie in this. Want to bring in this, okay. I want to drag this. So let's put this, drag this, that, okay. So we have this primary key being connected to this product key, right? So we have this going on as our connection. So having established this, it now makes it easier for us to say that we can even generate the codes from this. So how do we do that? We can go here and then export. You can export, you see this? So we can export it into a different format. So you see, MySQL has been taken. So assuming you're using Postgres or you're using Oracle, you can actually get. So you see that we didn't have to write all this. You get it. So if I want to work on a new product, I can come in here, go to home, go to database. Now, first of all, create. So this one will be, we say, order, order products table. So when I create it, and then go to the SQL. I'm still within the other. So when I come in here, I can actually copy all this, copy to clipboard, and it copies all that I want in here. All right. Then I will send it into my database. Uh, see, so I'll go into my database. Now I'll put this in here. So you see, I didn't have to do all this. I just needed to use the what do you call it? The Lucid chat to generate this. Okay. So I didn't have to do all this by myself. Okay. So once I get this done, I can go ahead and say go. Then it creates the customer, the order, and the product, still having in mind the connection. So see that the connection has already been established. We're not seeing it here. But when I go to more and then go to the design, see that it's able to establish that connection for me. So everything has been done already. I didn't have to do anything. So you see that this is the connection we have. Okay. This is the other table connection. So you see that what I established has been done here for me. You can see tables. Now bring this up here. Okay. So see that when I brought it in, you can see that it's established the connections for me, right? So this is basically how we can establish our connections. Okay, we can develop our design, our databases using Lucid, and then send it straight up into our application without having to struggle to create all this by ourselves. Lucid makes things easier for us. All right, so this is how far time will permit us. Okay, so instead of reusing the Visio in my work, I have found a better way to get this done instead of using the. So we can say we have covered all this. Okay, and so the your little assignment here will be to. So you see, when you finish, this is what we're supposed to get. So go and try your hands on the self-assessment. Okay, and use uh, the Lucid platform. Okay, this is the Lucid platform. Lucid platform. All right, so here we'll save it as order table. Okay. So I will expect you to be able to use the Lucid. Okay. Create an account and create it for us, and let's see how best. So you use it to answer this, perform normalization, and also create using, so in this case here, it says use Visio, but in my case, I expect you to use Lucid, all right, and get all this done for me, all right? Okay. So thank you so much for your attention. I hope we shall meet face to face next week. Thank you so much for your time.